Hello, this is Mr. Ensler, and this is the geometry review for the first part of Chapter 7. We split this chapter into two, and so this is the review for the first part. And the first thing we learned in Chapter 7 was the Pythagorean theorem. Of course, we already know the Pythagorean theorem. If you have a right triangle, then a squared plus b squared equals c squared. A squared and b squared, of course, are the legs. That would be the shorter two sides. And c squared is the hypotenuse, which is the longer side. Remember that the hypotenuse is always across from the right angle. So, when we set up number 1, we can do 3 squared plus x squared equals 7 squared. You can put the 3 and the x in reverse order if you like. It doesn't really matter which one is the a and which one is the b. Alright, and then we just solve this. So that's 9. I don't know what x squared is. 7 squared is 49. Subtract 9 from each side, and we get 40. And then we're going to take the square root of each side. We really don't want plus or minus. We only want the positive value, so just square root of 40, not plus or minus square root of 40. And then here, what we stressed a lot in this chapter was find the exact unknown side. Simplify any radicals, don't round, show work. So I need to simplify square root of 40. There's a couple different ways you can do this. One of the ways that a lot of people learn in algebra is just to take 40 and divide it any way you can, say 2 and 20, for instance, but just whatever way you want to do it. And then divide that one. How about 5 and 4? And then 4 can divide. And then the numbers that you have in the end, in this case we have 2, 2, 2, and 5. If you multiply all those by each other, you get 40. Every pair of the same number is a number that will make it outside the radical, and the numbers that are left over will stay in. So in this case, the 2 is going to be outside the radical, and then 2 times 5 is 10. That is going to be inside the radical. And so this is the answer, 2 square root of 10. That's how we simplify square root of 40. Another way that you could do this is to try and divide 40 by any perfect squares, such as 4, or 9, or 16, or 25, or 36, and so on. So I could say, well, I know that splits into 4 and 10, and I know the square root of 4 is 2, and then I have square root 10 left over. So however you get the answer, as long as you show your work and you get it right, either way is fine with me. Alright, here's another one, number 2. Let's do 8 squared plus x squared equals 17 squared. It is very important which side goes by itself. It has to be the hypotenuse side. It's not just the x that's going to be by itself. In this case, x is not by itself, at least not yet. So let's see here. 8 squared is 64. 17 squared is 289. Feel free to use your calculator. So then we'll subtract 64. And we get 225. Alright, take the square root. And before you just automatically start splitting up 225, if it's a number that you're not familiar with, especially a bigger number, try just taking the square root of it. And if you type into your calculator square root 225, it's actually going to come out evenly to 15. And so we didn't round. We did show our work. That is the answer. Number 3, here's another one. I'm going to do x squared plus 48 squared equals 50 squared. Alright, I don't know what these are off the top of my head, so I'm going to type it into my calculator. 48 squared is 2,304. And 50 squared is 2,500. Alright, I'm going to subtract the 2,304 from both sides. And on the right side, I will have 196. So take the square root of both sides. And actually, this one comes out evenly also to 14. So 14 is my answer. Sometimes it comes out evenly. Sometimes we have to simplify. Number 4, same directions. Alright, this time x is the hypotenuse. So 4 squared and 9 squared are going to be added together. And x is going to be on its own side. So 4 squared is 16, 9 squared is 81, 16 and 81 is 97. And then take the square root. Okay, 97, that's not very familiar to me. I'm going to just try typing in square root 97. And it doesn't come out evenly. I get like 9.8 something, something, something. So do not write down x equals 9.8. All right, don't do that. We don't want to round. We want an exact answer. So try dividing 97 by something. I'm going to try to split it up. All right, I know it doesn't divide by 2 because it's an odd number. Does it divide by 3? Nope. It doesn't divide by 4. Again, if it's not an even number, then it's not going to divide by any even number. Let's see here. 5, no. 6, no. 7. In fact, I can't find any number to divide 97 by. So that means in this case, x just equals square root 97. That's as simple as we can go in this case. All right, here's another one. A right triangle has a hypotenuse of 11 and one leg length of 7. What is the length of the other leg? I'll call that other leg x. And if you want, you could draw a picture. You don't have to. It says the hypotenuse is 11, so that goes by itself. And on the other side will be 7 and x. So we're just using the Pythagorean theorem. All right, 7 squared is 49. 11 squared is 121. If I subtract those, 121 minus 49, I get 72. And so then you take the square root of both sides, and let's see here. Does square root 72 come out evenly? No, it doesn't. I get like 8 point something. So you have two options with this one. You can just take 72 and split it up however you want. I think 8 and 9 is what comes to mind. And then 8 can split up into 2 and 4, and then 4 is 2 and 2, and then 9 is 3 and 3. And so in the end, what makes up 72 is 2 times 2 times 2 times 3 times 3. That's the prime factorization. So remember the rule. Every pair of the same number makes a number outside the radical. So square root 72 is going to equal 2 times 3, and then what's left over is square root 2. So 6 square root 2 is the answer. The other way that you could think of this one, when you have square root 72, you can divide it by a perfect square, say 36, with 2 left over, and we know what the square root of 36 is. It's 6. So you get the same answer either way. As long as you show your work and get the right answer, that's fine with me which way you do it. All right. Number 6, find the value of x as well as the three sides. Okay, this one looks a little different because we got x's all over the place. We don't know what any of the three sides are. Not really. We have an expression, but we don't know the exact values. Well, even if you're confused about this, you should at least be able to set it up. So let's set this up. One of the sides is 5x minus 1, and I need to square that. If I just put a squared sign there, that's not really squaring it. That's only squaring the 1. So if I want to square it, I need to write it like this. And then we'll add that to the other side squared. And then that's going to equal 5x squared. Same thing here. If you just do that, you're only squaring the x. We want to square the whole thing. Now, remember what it means to have a parenthesis squared. This 5x minus 1 squared, that means 5x minus 1 times 5x minus 1. All right. The second term squared, x plus 2, that means x plus 2 times x plus 2. And the last, 5x times 5x. So don't forget what it means when there's a square symbol there. All right, I'm going to FOIL each of these. So with FOIL, I do firsts, outside, inside, lasts. So firsts are 5x and 5x. So 5x times 5x is 25x squared. Then we got outside. Outside would be 5x and negative 1. 5x and negative 1. If you multiply those, you just get negative 5x. Insides are negative 1 and 5x. So if you multiply those, you also get negative 5x. You might remember that every time you square a binomial where you times it by itself, the O and the I are the exact same. So that shouldn't be a surprise. All right, lasts are -1 and -1. So that equals +1 when you multiply those. All right, combine like terms here. I have 25x squared minus 10x plus 1. All right, let's go to the next one. So the firsts, x times x is x squared. Next is outside, x times 2 is 2x. Inside is also 2x. Lasts, 2 times 2 is 4. Okay, let's put those down here as well. X squared, the middle two become 4x, and then we have plus 4. All right, then on the other side of the equal sign, 5x times 5x is 25x squared. All right, we got to combine like terms and get everything on one side. Actually, the first thing I notice right away is that this is 25x squared over here, and this is 25x squared there. If you subtracted 25x squared from both sides, both of those would just go away. Works out kind of conveniently. All right, what do we have left after doing that? Well, we have x squared is the next highest. And then we have negative 10x and positive 4x. So you can combine those. What's minus 10 and plus 4 equal? It equals negative 6x. And then we have positive 1 and positive 4. Add those together and we get 5. And all of this equals 0 because we subtracted that. All right, now this is an equation that we can solve. You could either use the quadratic formula or I usually try to factor it when I can. So I'm going to look for a GCF. Is there a number I can divide all three of these by? No. So I'm just going to put down my two parentheses. I know the firsts have to be x and x. What we're doing here is we're reverse foiling. We're pretending that these two parentheses have been foiled together and they equal this. So now I'd go to the lasts, 5. I need two numbers that multiply to make 5, but they need to add together to make negative 6. So, for instance, 5 and 1, they multiply to make 5, but they do not add to make negative 6. How about negative 5 and positive 1? No, that doesn't work. They don't add to make negative 6, and they also don't multiply to make positive 5. But if they're both negative, now we get our answer. And then what you do with that is you set each of these factors equal to 0 and solve each one. And so over here, x equals 5. Over here, x equals 1. And the original directions say to find x, which we did, and it also says to find the value of the three sides. So, well, it looks like we have two different cases. If x equals 5, what would the sides equal? Well, this side up here would be 25. This one right here would be 7. And this one right here would be 24. So, I'm just going to go ahead and write that down. 25, 7, and 24. So if x is 5, those are the three sides. What if x is 1? Well, that would mean this side is 5, this side is 3, and this side would be 4. Oh, it would be like a 3, 4, 5 triangle. Okay. And when we've done these problems in class, oftentimes we get one answer that doesn't work because it creates a negative value. We don't have that here. Both of these answers of x equals 5 and x equals 1 work. What that means is that the original triangle, the way that it was set up kind of ambiguously so that there's two possible combinations for a triangle with these characteristics. So there's two possible answers. We verified it and it makes sense. All right, here's another one. Same type of thing, same type of problem. So I'm going to set this up. X minus 6 squared and x squared. And then the hypotenuse is 2 radical 17 squared. Okay, so this x minus 6 squared, that means I'm going to times it by itself. The firsts equal x squared. Outside is negative 6x, and inside is also negative 6x. So I'm just going to add those together and get negative 12x. And the lasts, negative 6 makes positive 36. All right, then I have x squared. And then over here, 2 radical 17 times 2 radical 17. Well, the 2 times 2 is 4. The square root 17 times square root 17 is just 17. So what is 4 times 17? You can type that into your calculator and you get 68. Okay, let's put together some like terms. The x squared and the x squared make 2x squared. And then I have negative 12x and plus 36. And I need to move that 68 over. Okay, and so I have 2x squared minus 12x, and then 36 minus 68 is negative 32. So minus 32, and that equals 0. All right, now here's the part where I try to factor, or if you'd rather, you could use the quadratic formula. When I factor, the first thing I want to do is look for a GCF. In the last problem, we didn't have a GCF because x and minus 6 and 5, they have no common factors. But in this one, there is a common factor. All of these terms can be divided by 2, and so therefore they should be divided by 2. So just have x squared, and then minus 6x, and then minus 16. Now we're not going to do anything with that 2, it's just going to sit out front here, but it reduces these numbers here, and it makes it easier to find our answer. Now I'll go ahead and put the 2 parentheses down. I know the firsts have to be x and x. You can put this 2 just here, it gets brought down. And I'm looking for 2 numbers that multiply to make negative 16, but add to make negative 6. 2 numbers that multiply to make negative 16 and adds to make negative 6. And the 2 numbers that we're looking for are 8 and 2, and one of them has to be negative, and that's going to be negative 8. The other one will be positive 2. You could have those in either order, but the 8 has to be negative, the 2 has to be positive. So now we'll set those equal to 0, and we're going to get 2 answers, just like last time. So in this case, x would equal positive 8. In this case, x would equal negative 2. Now, let's go back and figure out if those answers make sense. So if x equaled 8, then this side would be 8, that's fine, and this side would be 2. 8 minus 6 is 2. So, alright, there looks to be nothing wrong with that. I'm going to write down those answers. So x equals 8, the side lengths are 8 and 2. Alright, if x equals negative 2, that means this side would be negative 2 and this side would be negative 8. And that doesn't make sense. You can't have side lengths of negative 2 and negative 8. If you're wondering why that happens, why sometimes we get an answer that doesn't work out, because that's what's happening. I'm going to reject this answer. If you circled it, you get it wrong. X does not equal negative 2, even though I know that was one of our answers. If you're wondering why that's the case, it has to do with the fact of when you square root something that's being squared, there's a positive and a negative answer. And in this case, since we're dealing with distances, a distance of a triangle can't be negative. So that's why we have to reject that answer. Alright, on to the second page. These first 4 problems all tell you to find the area. And you know, or you need to know, that area of a triangle is 1/2 base times height. Alright, and so in number 8, we're looking at the whole triangle, the isosceles triangle. I know that this has visually been split up into 2 triangles for you, but these aren't isosceles, at least we don't know they are. The one that we do know is isosceles is this whole triangle because these 2 sides are both 13, they're the same. So, area equals 1/2 base times height, as we said above, so that means in this case, area equals 1/2, 18 is the base, and we don't know what the height is. So, in order to find the height, what we're going to do is we're going to take just one of these triangles. I'm going to take the one on the right, and I know it has a height of h. I don't know what that is. I know it has a hypotenuse of 13, and because this is an isosceles triangle, the height line, the altitude, is going to split the base evenly into two. So that means this and this will be the same, so they're both 9. And now we have a right triangle that we can solve to figure out the height. So I'm going to set this up. h squared plus 9 squared equals 13 squared. 9 squared is 81. 13 squared is 169. And 169 minus 81 is 88. So h squared equals 88. We're going to take the square root of both sides. So square root 88. All right, that does not come out evenly, but perhaps we can find a perfect square that goes into 88 that does. Remember our list of perfect squares, 4, 9, 16, 25, and so on. I'm pretty sure that 4 works. What do you get when you divide 88 by 4? Well, 88 divided by 4 is 22. Can 22 divide by any of these perfect square numbers? No, it can't. And we know the square root of 4 is 2. So 2 square root of 22. Now that is not the answer. That is just what h equals. That's what I need to plug in to my formula there. So 1/2 times 18 times 2 square root of 22. Sometimes this can confuse people because we have all of these numbers outside of the radical, and then we have the number inside the radical. And what do we do with them? Well, what you're going to do is you're going to multiply all of these on the outside together, and then you're just going to leave square root of 22 by itself there. And so what do we get? 1/2 times 18 times 2 is just 18, and then the square root 22 will be sitting right beside it, but we're not going to change the square root 22. And we do have a label here. This is inches, so square inches. That is the area. Now remember, there are a couple different ways that you can simplify this radical. When I got square root of 88, this is one way of doing it. If you'd rather, you can just take that 88 and split it up however you want. Let's say 2 and 44, and then 44 can split into 4 and 11, and then 4 can split into 2 and 2. And so what you have at the end, what makes up 88 is 2 times 2 times 2 times 11. Remember, our rule is that every pair that's the same is a number that makes it outside the radical, and then the other numbers left over go back in the radical, and 2 times 11 is 22. So feel free to do it that way. All right, here's another one. Same kind of problem, number 9. So again, I know that I'm going to do 1/2 base, which is 48, times height. And I just need to find the height, and then I can plug it into this formula. So this is also an isosceles triangle. These two sides are going to be the same. So 48 cut in half is 24. And so I'm going to think of it as this right triangle, which has a base of 24, we don't know the height, and a hypotenuse of 51. And so I'll set up the Pythagorean theorem. So you see how these problems just use the Pythagorean theorem in a different way in order to find an area. All right, 24 squared is 576. 51 squared is 2,601. So I'm going to subtract the 576 from the 2601, and I get 2,025. Now remember, if you get a bigger number that you're not familiar with and you're trying to find the square root of it, because that is what we're trying to do, we're going to take the square root. Don't forget that that might be a perfect square in itself. So I'm going to enter into my calculator square root 2,025. Alright, it came out evenly. The square root of 2,025 is 45. Again, that's not my answer. Remember what you're doing. You are trying to figure out the area. So that means that the height is 45. And so I'm going to do 1/2 times 48 times 45. And I get 1,080. So The area is 1,080 square meters. Make sure to label your answer if there is a label given. So that time we did not have to round, and we didn't really have to simplify much. We could just solve it. Everything came out evenly. Okay, on to number 10. Same type of problem. So I can immediately split the base of this triangle, 42, into 21 and 21. Again, the reason why I know that is because this is an isosceles triangle. And if you draw a height line in an isosceles triangle, it will split it into two right triangles. So, the right triangle that I'm looking at, we don't know the height of it. We know the hypotenuse is 75, and we know the base is 21. So, 8 squared plus 21 squared equals 75 squared. 21 squared is 441. 75 squared is 5,625. I'm going to subtract the 441 from the 5,625. And I get 5,184. And let's just see if that works out evenly. And it does. The square root of 5,184 is exactly 72. So, area of this whole triangle is 1/2 the base, 42, times the height, which we now know is 72. So I'll just type that in to my calculator, and it tells me it equals 1,512, and our label here is feet. So square feet. Number 11, a final type of these problems. So by now, if you haven't noticed, the pattern is basically we are figuring out the height and then taking that and plugging it into the area formula. So in this case, this 80, we're going to split it into 40 and 40. And so I'm going to set this up 8 squared plus 40 squared equals 55 squared. So I'm treating this like the hypotenuse. 40 squared is 1,600. 55 squared is 3,025. I'm going to do 3,025 minus 1,600. And I get 1,425. And then I'll take the square root of that, and it doesn't come out evenly. I get like 37.7. So that means we need to simplify this. So let's just try and divide it by anything that we can. And I see that the last digit is 5. Actually, the two last digits are 2 and 5. So I'm going to divide this by 5. So 1425 divided by 5 is 285. Okay, well that brought it down considerably. I know I can divide 285 by 5 also because its last digit is 5. And I get 57. 57. I know it doesn't divide by 2. Does it divide by 3? Yes, it does. 3 and 19. And now I know 19 can't divide by anything at all. Alright, so if you're simplifying it this way, remember the rule is that every pair of numbers, that makes a number outside the radical. And the numbers that you have left are going to multiply back together inside the radical. So that's just going to be 5 square root of 57. That is the height. I need to plug that into the area formula. So area equals 1/2. Area equals 1/2 times the total base of 80 times 5 square root 57. Remember what we're going to do here. We are going to multiply 1/2 times 80 times 5. So what do I get when I do that? 200. And then the square root 57 is just going to go on to the end of that. Everything is timesing here, so we're just saying 200 times square root of 57. My label is square yards, and that is the answer. Alright, the next several problems tell you to figure out what kind of triangle the three numbers, the three sides represent. Is it acute, right, or obtuse? Now we know what it will look like if it's a right triangle. If number 12, if this were a right triangle, 10 would be the hypotenuse, so it's going to be on a side by itself. And then 6 and 8, we can put on the other side, and we can use the Pythagorean theorem, right? You plug the two small sides into one side, hypotenuse into the other, and so we would get 36 and 64, and look at that. It really does equal 100. So if you can plug the three numbers into the Pythagorean theorem, and it works, the left side really does equal the right side, that means it's a right triangle. The question is, what happens when it doesn't work? All right. So in number 13, I can see that 16 would be the hypotenuse part, so that's going to be by itself, and the other numbers will be squared and added together. So it's kind of like we're testing, is this really equal? You know, does 11 squared plus 13 squared really equal 16 squared? Well, let's find out. 11 squared is 121, 13 squared is 169, 16 squared is 256, okay. And 121 plus 169 is 290. So no, they're not equal. And so what we learned is that whichever side is bigger tells you something. If the hypotenuse side is larger, that means it's an obtuse triangle. If the hypotenuse side is smaller, like in this case, that means it's an acute triangle. All right? So I showed my work, and I can just say acute. You don't really need any other explanation other than the work you've shown. All right, we're going to do the same thing with number 14. Except with number 14, I know I have one side length of 13, another of 18. I don't really know how long this is compared to 13, 18. You know, is 3 radical 55, is that the smallest side? Is that the middle side? Is that the largest side? I don't know. So what I would do is I would enter it into your calculator. I would enter in 3 times square root 55 and press equals. And it won't come out evenly, I know that, but it'll give us an approximation. And it approximately equals 22.2. Okay, so actually this is the largest side. So it's going to go by itself. So you can do 13 squared plus 18 squared. Does that equal 3 radical 55 squared? Now, a shortcut that we mentioned in class is if you have already entered this into your calculator and you have this 22.24859.546 number on your calculator, you can just press the squared button and it will square it for you. And so when I do that and then press enter, I get 495. And then we got to square the other ones also. 13 squared is 169. 18 squared is 324. And then I need to add those two. And I get 493. Ooh, so this one's close. In this case, the hypotenuse side. In this case, the hypotenuse side is larger. And so that means this is obtuse. If you put an equal sign here, I don't mind. Obviously, they're not equal, so technically you would be lying, but that's okay. As long as you have the right answer and you've shown your work, that's fine. Just so you know, you don't have to use the calculator to come up with 495 here. There are other ways that you can do that, or at least you don't have to type it in like that. Because what does this mean? It means 3 square root 55 times 3 square root 55. So the 3 times 3 equals 9. The square root 55 times square root 55, that equals 55. So really, you're just doing 9 times 55, and it equals 495. And it equals 495. So use your calculator to help you out, but realize that you shouldn't have to do this in order to come up with 495. You should be able to come up with 495 just using what we've learned before. All right, number 15. All right, in this one we have 2 sets of radicals. So I need to type both of these in. 2 square root of 2 is approximately 2.8. And if I square it, I'm just going to go ahead and square it right now, it equals 8. 6 square root of 3 is approximately 10.39. And if I square that, it's 108. So in this case, I just squared them both right away. We know we're going to have to square these. So out of my 3 original numbers, 2.8, 10, and 10.39, the 10.39 number is the largest. That's the number that's going to go on its own side. Sometimes I like to put the hypotenuse first. So still make sure to show your work. Tell me what you're doing. And we want to know that you are squaring everything and you're setting it up according to the Pythagorean theorem. So 6 radical 3 squared equals 108. 2 radical 2 squared equals 8. And 10 squared is 100. And hey, look at that. They are equal. And so that means this is a right triangle. So that time I put the hypotenuse on the left side. It doesn't really matter which way you set up the Pythagorean theorem. Alright, 6, 8, and 9. At last. Kind of a normal looking one, right? So if this is a right triangle, 9 would be the hypotenuse. I'm going to do this one the same type of way where I start off with it. And then we'll put the 6 and the 8 together. And 9 squared is 81. 6 is 36. 8 squared is 64. And if I add those together on the right side, I get 100. One of the reasons why sometimes people like to put the hypotenuse first is because it really puts the focus on the hypotenuse. Our rule is if the hypotenuse side is bigger, it's obtuse. If the hypotenuse side is smaller, like in this case, it's acute. So however you want to remember it is fine with me, as long as you show the work and you get the right answer. Number 17, 2, 4, 5. Okay, so 5 would be the hypotenuse side, and then we're going to square 2 and 4 and add those together. And so we're going to get 4 and 16. So in this case, the hypotenuse side is larger because 4 and 16 makes 20. So this one is obtuse. Okay, got a couple more. Number 18, 15, 15, 20. Ooh, this one's kind of weird. 2 of the sides are the same. Well, that just means it's an isosceles triangle. 20 is going to be the hypotenuse, so that's going to go on its own side, and the 15s are going to be on their side together. So 15 squared is 225. Both of them are going to be 225. 20 squared is 400. 225 plus 225 is 450, and the hypotenuse side is 400. So the hypotenuse side in this case is smaller, right? The crocodile does not want to eat the hypotenuse side, it wants to eat the other side, so this is acute. Number 19, 12, 16, and 20. Okay, so the hypotenuse side goes by itself. The smaller sides get squared and added together. 12 squared is 144, 16 squared is 256. What's 144 plus 256? Hey, look at that. It's 400, exactly the same as the other side. So in this case, it is a right triangle. If the Pythagorean theorem works perfectly, it's not acute or obtuse. The Pythagorean theorem is for right triangles. The first 2 pages of this packet represent the first 2 lessons of Chapter 7, 7.1, 7.2. This page is all about 7.3. And in Lesson 7.3, we learned about similar right triangles. And we learned that if you have a right triangle, so I'm looking at this big right triangle, STU, and if you draw a altitude line in that right triangle, then what happens is 2 other right triangles are created. This is also a right triangle here, and we can see as marked, this one is a right triangle. So now we have 3 right triangles. We have the big one, we have the medium-sized one, and we have the small one. And all 3 of those are similar. They all have similarity. And that's why you see a proportion set up here. That's why we're talking about proportions. Because in similar shapes, you can set up a proportion. So what we're going to do is we're going to compare two triangles, and we're going to want to line up like the hypotenuse with the hypotenuse, or the short leg with the short leg, or the long leg with the long leg. So you want to review how in any right triangle, the longest side, let's say look at this big right triangle, the longest side would be the hypotenuse. The other two sides are called the legs, and so we'll call one of them the short leg and one of them the long leg. So what has been set up so far? Let's look at the first part of the proportion, RS over RU. Okay, RS is right here, and RU is right here. So it appears we're looking at the small triangle, RS over RU. Right? We're not looking at this triangle, and we're not looking at the whole thing, we're just looking at this one. And in that small triangle, how would you categorize RS and RU? Well, this is the hypotenuse, so these are legs. RS is the shorter leg, RU is the longer leg. So I'm going to make a little note here. Short leg over long leg. And so since all three of these triangles are similar, the second part of this proportion is going to follow the same pattern, but it's going to be about either the medium triangle or the big triangle. It's going to be about one of the other ones. So let's take a look. RU. Okay, so we're reusing RU. So RU is the short leg. It's the short leg of what triangle? Well, it's not the short leg of this triangle. It's not the short leg of the big triangle, because RU isn't even really part of the big triangle. It must be the short leg of the medium-sized triangle. And yeah, it looks like it is. UT is the hypotenuse, RU is the short leg, and RT is the long leg. And that's what we want. We want short leg over long leg. And so what goes right here? That would be RT. That's my answer. Now, if you know what you're doing with this question, it should only take you about 10 or 15 seconds to answer it. I've just spoke for 2 or 3 minutes on it, but that's because I'm going back and reviewing. Let's take a look at another one. All right, 21. What do we got? We got EG, that's right here, and FG, that's right here. So that means we're looking at the overall big triangle. And in EG and FG, EG would be the longer leg, FG would be the shorter leg. So we're doing long leg over short leg. And so I want to follow that same pattern with the other triangle. I don't know which one's going to be. Let's take a look. Blank over DG. Where's DG? Here's DG. So DG has to be the short leg of a triangle. Well, it's either the medium-sized triangle or the small triangle. If we look at the medium-sized triangle, and we look at all three, yeah, DG is the short leg. Over here in the tiny triangle, DG is not the short leg. It's the longer leg, and we want it to be the short leg to follow the same pattern. So we're looking at this triangle right here, and we want long leg over short leg. So what's the long leg? That would be DE, or ED. And so that is my answer. All right. Number 22, same kind of deal. BC over BD. And this is a right angle here, so yeah, it looks like we're doing long leg over short leg. Alright, so that means the other fraction is also going to be long leg over short leg. So let's take a look. CD is our long leg. Here's CD. And if you're thinking, wait a minute, CD isn't the long leg, CD is the hypotenuse. Well, you're not wrong. CD is the hypotenuse of this medium-sized triangle, but we want it to be the longer leg to follow the same pattern. So how could this be the longer leg? Well, if you look at the whole right triangle, CD is the longer leg. And so what's the shorter leg of the whole right triangle? That's AD. And so that's my answer, AD. So you don't have to show a lot of work for these. It's mainly a thinking exercise. All right, here's another one. RS over RW. Okay. RS and RW. It looks to me like we're just looking at this small triangle right here. RS is what for that small triangle? Well, where's the right angle? It's not here, it's not here. This is the right angle. So RS is the hypotenuse, and RW looks like it's the short leg. So we're doing hypotenuse over short leg. So SW is the short leg, and we need to find the hypotenuse of that same triangle. Now, which triangle is SW the short leg of? It's not this triangle on the left. SW would be the longer leg of that. SW is the short leg of this medium-sized right triangle. And so the hypotenuse of that is ST. So ST is the answer. That's the side that matches up. Okay, so the next several problems, you're going to be doing that same thing, except more. You have to set up the proportion this time, and then you also need to solve it. And, just like before, we want to simplify, don't round at all, and of course, show your work. So there are many different ways that you can approach a problem like number 24. What I usually like to do, though, is start with the x. So if you have no idea what to do, maybe start with the x. And we're going to set up a proportion. X over something equals another fraction. And so pick another number in the same triangle as x. The way I see it, I'm looking at this triangle right here. And in this triangle, x is the longer leg, and 8 is the shorter leg. So I'm going to choose to set this up as x over 8. Alright, now I need another triangle with a long leg and a short leg where I know both of them. So let's take a look at this triangle right here. In this triangle, 8 is the longer leg and 4 is the shorter leg. And now I just cross multiply. 4x equals 8 times 8 is 64, and then 64 divided by 4 is 16. So the answer is 16. Now, what if someone wanted to set this up as like 8 over x? Could they do that? Sure, of course they could. Their other fraction would then be different. It would be 4 over 8. What if someone wanted to set this one up as x over 4? That actually wouldn't make a lot of sense, because x over 4, x is the longer leg of its triangle, 4 is the short leg of its triangle, so I don't know if you'd really want to do that. So that's why I usually just stick in the same triangle. And x and 4, together they make up a whole side of a triangle, but separately they're not really part of the same triangle together. Alright, here's another one. Again, I'm going to start with x over something equals another fraction. So how about x over 12? So if I do x over 12, that would be short leg and a long leg. And so then look at another triangle, say this one here, and we want short leg over long leg. So that would be 3 over x. Cross multiply, we get x squared and 36. Take the square root, and the square root of 36 comes out evenly to 6. Now another point that might be confusing is the fact that in the first fraction I put x on top, but in the second fraction I put it on bottom. And someone might say, doesn't x correspond with x? Shouldn't it be in the same order that this x is in? And what's going on here is that in the first triangle, this one over here, x is the short leg, 12 is the long leg. But in this triangle, x is not the short leg anymore. It's the long leg, so that's why it's on the bottom. So what can sometimes happen is you use the same letter or the same number, but that side is different things to different triangles. This side in the triangle on the right is the short leg, but that same side over on the left is now the long leg. Okay, number 26. I'm going to do x over, how about 4? Alright, x over 4. If I do x over 4, that means I'm looking at this triangle right here. And in this triangle right here, x is actually the hypotenuse, and 4 is the long leg. So I want to set up another triangle where I compare two sides, hypotenuse and long leg. And let's see here. This triangle over here, this tiny one on the left, I don't have enough information. So remember, don't forget that the large big triangle also counts. And what's the hypotenuse of that? It's 5. Because I need to add together the 1 and the 4. Together it's 5. And the longer leg is x. So it's another case of we're reusing that same side, but it's different in each triangle. So square these and we get x squared. 4 times 5 is 20. And then we need to take the square root of that. And that does not come out evenly. I would split that into 4 and 5, and I know the square root of 4 is 2. So 2 square root of 5 is my answer for x. A general note about all of these types of problems that I've been doing. Again, if you set up the problem slightly differently than the way I set it up, you could still get it right. So if you get the right answer and you set it up differently, that's fine as long as you showed your work. Alright, number 27. I'm trying to find y. I'll do y over 2, how about? Now if you're like, well, I would rather do y over 8. That's fine, you can do y over 8. Your work will look a little bit different than mine, but you should get the right answer. So if I'm comparing y and 2, y is the long leg, and 2 is the short leg. So now let me look at this triangle here, and this triangle, 8 is the long leg, and y is the short leg. So now I'll times y by y and get y squared. 2 times 8 is 16. Take the square root, and we get 4. That one worked out evenly. Alright, number 28. Let's see here. I need to find out what x is. Now what I would usually do is I would set this up as, say, x over something equals another fraction. And so let's say I wanted to look at this triangle right here first. I would do x over 8. The issue with this, though, is it's kind of hard to tell which side is longer, x or 8, right? One of them has to be the short leg, one of them has to be the long leg, and I don't know if I can assess that visually. So let's back up a little. And this is kind of interesting. This might remind you of a problem that we did before. These two are the same. That means that this line, x, is a perpendicular bisector. And what we have noticed in the past is that if a perpendicular bisector meets exactly at the vertex of the opposite side of the triangle, that means it has split this whole triangle into two. This was an isosceles triangle to begin with. And so what you can see is actually this makes two congruent triangles. This triangle on the left is congruent to this triangle on the right. Alright, now how does that help us find x? Well, if this is a right triangle up here, and these two sides are the same, so let me just draw the big triangle. If you have a right triangle and these two sides are the same, that means these two angles have to be the same. And so what will each of these angles be? They would have to be 45 degrees. Alright, so that means this is 45 and this is 45. And I know this is 90. That means each of these has to be 45 also. And so what that is going to mean is that 8 and x are equal. Those are the same. This would be a case where there might not be a lot of work to show with this one. I don't know if you're going to have success setting this up as a proportion like we did with the other ones that we just did. Alright, number 21.9. This one looks a little more normal. or at least like the ones we were doing before. So I'm going to say z over 4. If I look at z and 4, those are in the same triangle. Z is the short leg and 4 is the hypotenuse. So I'm doing short leg over hypotenuse. So now I need another short leg over hypotenuse. Well, if I look at the medium-sized triangle, I don't know what the short leg is, and I don't know what the hypotenuse is, so I can't use that. If I look at the whole triangle, the short leg is 4, and I don't exactly know what the hypotenuse is, but I know it's 6 plus z. So I can at least write that. And now I can solve this. So 4 times 4 is 16. And on the other side, I have z times 6 plus z. So I'm going to need to distribute that. You can see this one has a little bit more work to it. So I'm going to get 6z plus z squared. I'm going to get everything on one side. Let me subtract the 16. And then let me reorder this. It's going to be z squared plus 6z minus 16 equals 0. Or you could put the 0 on the left side, either way. This is another quadratic equation, where you can either use the quadratic formula or you can factor it. There's no common factor to all three of these, so I'm just going to go right to the factoring. I know it has to be z and z. What two numbers multiply to make negative 16, but add to make 6? That would be positive 8 and negative 2. And then set each of these equal to 0. And so we get two answers. One of them is negative 8. The other one is positive 2. I don't think negative 8 is going to work as an answer, because that would mean this side has a distance of negative 8. So we're going to reject that, but z equals 2 is a perfectly good answer. Alright, the last thing that we learned in Chapter 7, right before winter break, was about special right triangles, specifically 45, 45, 90 right triangles and 30, 60, 90 right triangles. And what we learned are some shortcuts and some things to help us solve. So here the directions say, find the value of the variable, write your answers in simplest radical form, and interestingly it says you may or may not need to show work. So you don't have to show work with these. In fact, on some of them, we might not. But let's review what we learned about 45, 45, 90 triangles. That's what this one is. It's a 45, 45, 90 triangle. That means it's isosceles. If two angles are the same in a triangle, the two sides across from them are also the same. So both these sides are congruent to each other. And what we learned is you take a look at one of the legs. In this case, they're both 4. And to get the hypotenuse, you just times that leg by radical 2. So x is 4 times radical 2. And that's your answer. That's all you need to do with this one, and that is simplified. You don't need to do anything more. If you're looking for a reason as to why that is, well, you could always use the Pythagorean theorem. You know you have 4 squared, and 4 squared equals x squared, and that's 16 and 16, and then that's 32. Then you take the square root, you get square root 32, and then you got to simplify it. So let's split it into 16 and 16. So that's 2 times 16. And then we know the square root of 16 is 4. So we end up with radical 2 times 4. Now, it'd be nice to not do all that work, and you don't have to. So it'd be nice just to memorize that in a 45, 45, 90 triangle, if you know one of the legs, just times it by radical 2 to get the hypotenuse. Here's another one, number 31. We know the leg is 6. Actually, both legs are 6. So the hypotenuse is just 6 times radical 2. And that's the answer. Now, number 32, this is kind of the opposite situation. We do have a 45, 45, 90 triangle, but we don't know what the leg is. We know the hypotenuse. So it's kind of like this. Whatever the leg is, we know if you times it by radical 2, it will equal 3 radical 2. So you can set up a little equation, or what you're going to end up doing to get x by itself is you're going to end up dividing by radical 2, And in this case, the radical 2's cancel out and we just get 3. And hopefully that makes sense. We're saying, like, what number right here times radical 2 equals 3 radical 2? Well, it'd have to be 3. So, to sum up a 45, 45, 90 triangle, if you know the leg and not the hypotenuse, just times the leg by radical 2, and you'll get the hypotenuse. If you know the hypotenuse but not the leg, divide by radical 2 instead of timesing. So that's what I'm going to do with number 33. I know the hypotenuse is 9 radical 2. I don't know what the leg is, so I'm going to divide 9 radical 2 divided by radical 2. Oh, look at that. How convenient. Those just cancel out again. So x equals 9. Alright, then we get into 30, 60, 90 triangles. There's a couple different things we got to know here. And 34 is a good one to start on. What we learned about 30, 60, 90 triangles is that the short leg, if you times it by 2, that will give you the hypotenuse. So short leg times 2 is going to equal the hypotenuse, which is 4. To get the longer leg, y in this case, take the short leg times radical 3. So we're going to times it by radical 3. So y is 2 radical 3. Okay, now that works out great when you know what the short leg is to begin with. You just times short leg by 2 to get the hypotenuse. You times it by radical 3 to get the longer leg. What happens if you don't know what the shorter leg is? Well, you're going to divide. You'll just do the opposite. So here in number 30, I know the hypotenuse is 10, but I don't know the shorter leg or the longer leg. Well, the shorter leg is our key, so you always want to figure that out first if you don't know it. Now, what was our rule? If you know the shorter side, shorter leg, times it by 2 to get the hypotenuse. So we're just going to do the opposite to get back to that side. Instead of timesing by 2, we're going to divide by 2, and that will tell us the short side, which is 5. Now that we know the short side, the rule is to get the longer side, times it by radical 3. So the longer side is just 5 radical 3. Now, when we were doing some of the other ones on this page, say like number 30, there was a way to figure out number 30 even if you didn't know the handy-dandy rule of just timesing by radical 2. You could have used the Pythagorean theorem. On one like number 35, there's no other way to do it. You just have to know this rule of how to deal with a 30, 60, 90 triangle. So there is some memorization involved, without a doubt. Alright, here's another 30, 60, 90. And in this case, I know the longer leg, but I don't know the hypotenuse or the shorter leg. So let's figure out the shorter leg first. The rule is if you know the short leg, times it by radical 3 to get the longer leg. So we're going to do the opposite. We're going to take the longer leg and divide it by radical 3. And look at that, how convenient. Those just cancel out, and x equals 6. Alright, now that we know the shorter leg, to find the hypotenuse, we know we just multiply it by 2. So y equals 12. Now, these are right triangles. So if you're ever thinking, oh, I don't know if I did it right or not, you can always plug it into the Pythagorean theorem and check it. You could do 6 radical 3 squared plus 6 squared equals 12 squared. Use a calculator to help you, and that's just one way to kind of check your work to see if you're doing it right. Number 37, okay, I don't know what the short leg is. So our rule is, if you know the longer leg, divide it by radical 3. Well, what's radical 3 divided by radical 3? That would be 1. So x is 1, and to find the hypotenuse, times that by 2. So y is 2. So you don't really have to show much work on these. There are places where you could if you wanted, but that's kind of the point, is to learn these shortcuts and let it be a convenience for you. Okay, our last two regular problems, same type of thing going on here. Number 38 is a 30, 60, 90 triangle, and I know the hypotenuse, but I don't know the shorter leg or the longer leg. So let's remember, how do you get from short leg to hypotenuse? You times it by 2, so we're going to do the opposite. We're going to divide by 2. And when you divide it by 2, only the 14 and the 2 actually divide, so the short leg, y, is 7 radical 3. And to figure out the longer leg, you multiply that by radical 3. So 7 radical 3 times radical 3. Well, radical 3 times radical 3 is just 3. So 7 times 3, 21. X equals 21. Alright, number 39. Let's see here. Is this a 30, 60, 90? Or is it a 45, 45, 90? Or is it something else? Well, what are we given? We're given that this side and this side are the same. It's isosceles. That means these two angles are the same. Ah, this is a 45, 45, 90. So we got to go back to those rules. You got to switch gears. And in a 45, 45, 90, if you know what the shorter leg is, or really either of the legs because they're the same, you multiply it by radical 2. So to go backwards, we need to take the hypotenuse and divide it by radical 2. Now those do not cancel out like we've seen in the past. But you also can't just leave your answer like this. We need to simplify it. And so what we need to do is get rid of the radical 2 that's in the bottom. So we're going to multiply both top and bottom by radical 2. We've done this many times. It's called rationalizing the denominator. So on top, we're going to have 2 square root of 6. On bottom, we'll just have 2, because square root of 2 times square root of 2 is 2. Now, those 2's do cancel, and so x equals square root of 6. Alright, the last problem. Write about one example of how the Pythagorean theorem could be used in solving a physical problem. So, we're always trying to connect math to practical ideas, and the Pythagorean theorem comes up a lot in real-life situations, especially when you buy a house like I did this past year. So, give an example of how you could actually use the Pythagorean theorem, and the directions say be specific. Think of measuring things, or yard layout, or a room layout. Give one specific example and use actual numbers, and then solve the problem that you create. So, here's just a situation that I'm just making up off the top of my head. You can't use mine. You got to come up with your own situation. So let's say you are right here at this point, and your friend is over here at this point. And your friend calls you and says, hey, I need a ride, come pick me up. And you happen to know that you are exactly 4 miles north of your friend. So you could drive 4 miles south down to your friend. You'd be kind of at the same level. And you also know that you are 3 miles west of your friend. So if you drove 3 miles east, you could pick up your friend. So one way that you could pick up your friend is you could take these roads. Maybe these roads have higher speed limits, or they're faster in some way. And so you could go down 4 miles and over 3 miles. And your total would be 7 miles. Or, using the Pythagorean theorem, this forms a right triangle. If there was a diagonal street that went there, you could figure out what that distance is. You could say 4 squared plus 3 squared equals d squared. And so when you solve this, you would figure out that that distance is 5 miles. Now you would need to write all this out. This is the exact same problem that I gave in the answer key. And you see there I wrote it out. And that's what you would need to do. You would need to write out, maybe give an example, draw a diagram of how this would work. There's a bunch of other examples. I don't want to take them from you, and if I say them, then you're basically just going to be copying me. So come up with some way that you use the Pythagorean theorem and use specific numbers. Think of a situation that involves the numbers 3, 4, 5. Those are easy to use. Or you could double that, 6, 8, 10. That would be another one that you could use. And there's a variety of others. Good luck in your studying.